Hi, my name's Richard, and today we're going to be talking about recursion. Hi, my name's Richard, and today we're going to be talking about recursion. Hi, my name's Richard, and today we're going to be talking about recursion. Hi, my name's Richard, and today we're going to be talking about recursion. Hi, my name's Richard, and today we're going to be talking about recursion. Hi and welcome back, and thanks for watching as always. Today we're going to cover a little concept called recursion in order to fix our little problem with these islands that I'm calling them, the unreachable areas here like this. And I'd been thinking about this for quite a while actually, and trying to find a way that it was simple enough that I could put into a tutorial but not too complicated that it would bore people. Well, I don't know whether I can help you with the boring part. I hope you find this interesting. If you're not familiar with recursion, then I encourage you to watch this. This is something that all programming nerds and geeks should know. If you're going to sit down the pub with your the programming scholars with their sandals and socks on, then you need to understand recursion. Whether you want to sit with the real ale drinkers with their sandals and socks on, I'm not sure, but you should certainly understand recursion. If you understand recursion, then happy days. And what I thought I might do is I might actually just take a step back and talk about what it is. Now, recursion, in a nutshell, is whereby you have a function that calls itself. Now, maybe some alarm bells are ringing and you're going to say, well, Richard, hang on, how can something call itself? Surely it just gets stuck in an infinite loop. And you would be right. So you need to add some controls to make sure that it doesn't always call itself. The classic example of how this might work is along the lines of something for a factorial equation. Now, this is, like I say, this is completely separate, but I want to talk through this first so that you can understand how I removed the islands on this dungeon. So if you imagine that a factorial, for those of you that don't know, is a factorial of a number is it's itself times by every number underneath it. So 4 factorial is 4 times 3 times 2 times 1. So what's that? 4 times 3 is 12. Times 2 is 24, times 1 is 24, right? So 4 factorial is 24, and 5 factorial would be 5 times 4 times 3 times 2 times 1, which I think is 120, and so on. Now, you can think of an obvious way that you could do that. You could very simply say, well, I'll write a little script, a little for loop perhaps, that goes down each time and multiplies it by itself. But the officially geeky way to do this is to write a recursive function. So what I'm going to do is I'm actually going to do this in here. And I know this is a detraction from what we from the actual dungeon, but I know that a lot of you have also been asking along the lines of just learning to code. So what I'm going to do is I'm going to disable these scripts for now, and I'm going to create a new script, and we'll just call this C# script. We'll just call this recursion example. Recursion example. Oh, I might even call it factorial. No, let's call it recursion example. That's fine. And let's double click it and go into it. And what we will say here is we will have a function down here, public static int factorial, and it's going to take in a number int n. Alrighty. I say alrighty a lot, don't I? So I watch my videos back and I realise the things I say, and I keep saying okay, and you may remember. So apologies if I sound monotonous in all the things I do. I notice a lot of videos always have a lot of so's in them at the start of a sentence, and I think I probably do that as well. So please bear with me. Okay, so here's our function here, factorial. So we're going to pass in a number, and I want to know what it is times itself minus 1 times 3 times 2 times 1. Like I say, you could write something along the lines of this. So you say for brackets int I equals n. So let's have a count up here. Int value equals 0 semicolon. Okay, and then we'll say for int I equals n, I is greater than 1, I minus minus. This is the non-recursive way of doing it, by the way, just in case you're wondering what I'm up to here. And then we'll say. So what we're saying? We're saying our value equals. Hang on, let's get this right. So it's got to be 1, isn't it? So it's going to start off at 4. So it's going to be. I'm going to get this wrong now. 1 second. Excuse me. It's going to be value equals value times n, isn't it? So it's going to start off at 4, it's going to say 1 times 4, and then it's going to do 4 times, so it's going down 1 by 1. Let's just see if that works. Debug.log factorial By the way, it's usually used with an exclamation mark, but I'm not going to do that right now. Factorial of plus n equals plus value. Let's just see if that works. And we'll call it in the start method up here. So we'll just say factorial and put a number in there. Factorial 4. Okay, that looks good so far. So we've got our recursion example here. This is, and like I say again, this is going to be one of these ones that just kind of just sits there. We'll just drag it into the game manager like that. It's got an error, I think. Not all code paths return a value. Indeed. So let's just make that void for now because it doesn't need to return a value right now. Okay, go away. Thank you very much, and we'll run it. And I'll run the console. Factorial of 4 equals 64. So what did I do? Clear on play. Why is these things still running? Why is this still running? I thought I disabled them, but maybe. Oh, I'll tell you what I did. I did that cardinal error. No, I didn't. I did disable them. Let's do clear on play. Why are you appearing? Okay, I don't know why those are still there. I'm just going to do clear here, and now I'm going to run it again. Am I missing something? Have I attached it to something else? Oh, perhaps that's in the... Both of these are turned off. I'll have a look at that in a minute. Oh, there we go, look. Oh, no, the recursion example's there. Okay, I don't know why it's still running those. Factorial of 4 equals 64, so something's gone wrong. What am I doing wrong? 1 second. Yes, I'm sorry. It should be times I. There we go. Shift Control S. I'm still quite confused as to why. It's not attached to something else, is it? Directional light or something? No, I don't understand why that's running. I don't understand why these guys are running, given that... I'll have a look in a minute why that is. Alright, now let's just click on the console. There we go. Factorial of 4 is 24. Alright, now that's fantastic. We have a function here, but what about if we try to use recursion? And here we go. So what we're going to do is we're going to say up here, we'll say int factorial equals brackets factorial equals, factorial brackets 4. Okay. And this now needs to return an int. And what we can do now is we can say the following. You'll like this. You'll like this if you like your recursion. We're going to say if brackets n equals 1, return 1. Else return n multiplied by factorial n minus 1. Does that horrify you? I hope not. What we're saying here is we're going to return 1 if it is 1, otherwise return this number multiplied by whatever it is below it, and it's going to go through that loop. So let's just see if that works. We'll just run that up here instead. Debug.log factorial equals plus factorial. Okay, so you can see that, just to recap, you can see that this factorial here is calling itself. It's going, but it's got an out clause. It's not going to run forever because you can see because we're doing n minus 1, it's going to hit this and then return 1. So it's not going to keep calling itself, but it's going to keep calling itself while it's greater than 1. So let's give that a go. Console, and it's worked. Can you see there? Factorial equals 24. Let's just plug in the number in here. 5. Click that. I think we said 120, didn't we? There we go. Now you need to be careful. These things can get quite large. You can imagine that if it's calling itself, you can get these things called a stack overflow, where it's allocating more and more memory to itself. Things like factorial is usually okay, but if you plugged in a ridiculously large number, let's try 5,000. I don't even think that's going to work. I think the number's too large to begin with. Let's just see what comes up. Factorial equals 0. There you go. So that's clearly wrong. Let's try 500. Let's just see if we can get it to actually function at all. So, okay, so that's very interesting. I can only assume that it's past some limit. So let's just, I'm playing around now for the sake of it. Let's just try 100. I'm just going to see if I can get something that does work. It's not throwing an error though. It's still showing a 0. This is really curious. I'm going to try 10. I'm going to try 25. Keep going down until it doesn't break anymore. There we go. So about 25 is fine. Excuse me. It comes up with a reasonable number. Good. So that is a factorial. That is recursion. And if that's whetted your appetite to think, oh, I like the look of recursion, then have a check out the Towers of Hanoi, because that has I don't know if you know the Towers of Hanoi. It's the one that has the pillars that you have to move from one block to another, from one pole to another, and you cannot put a wider pole on a shorter pole. So it's a bit of a rule. It's a great little challenge. It's one of those things that kids get sometimes, and you can usually do it with 3. 4 starts to get tough. 5 gets even tougher. But it can be solved with a 3-line recursive function. So that if you're feeling really geeky, go and check that out. In fact, I might even do a tutorial on it, because it got me feeling a bit geeky again. So with that, let's talk about why I'm doing all of this for the sake of the script here. Now, so I'll just uncheck that, and I'll just uncheck the recursion there, and just double click redo those. Okay, and we're back in here. Now this is an example of one here that I've used here. I've kept the same seed, which is why it's the same map over and over again. You can see the section here, and it's obviously in the way. So what we're going to do, or not obviously in the way, you could leave it there, but I want to get rid of it. I know we've got these dead ends that we're going to have a look at, and we'll do that in the next tutorial. But for this tutorial, what I want to do is I want to traverse this map, and I want to find all of the basically the route, the whole map, and find the whole link here, and anything that isn't attached to it I want to remove. So in order to do that, I need to start working out how to traverse the map, and this is where recursion can come in, because what I can potentially do is I can start at a point up here, and if it's well, in this case a corner piece, let's just click on this one here. In fact, what I will do, let me quickly bring up my OneNote and just show you what I'm talking about. Hopefully I can find my, yes, this isn't great. I'm using my bamboo tablet here. Let me just draw a very small map. I'll try and do my bestest drawings. Here we go. Alright, look at this, guys, look at this. You're getting some live presentation skills. I never said they were any good presentation skills, but they're live presentation skills. So in the top left hand corner, I think we have, as you know, we have to have this one here, and what we could potentially do is we could say, okay, well, I'm going to traverse this map, so what I'll do is I'll mark that one as visited, and then I will look at this one over here and the one below it. So we could call a function that calls exactly the same thing on the one below, and a function that calls the one on the right. And let's just say that's a straight line. Well, okay, well, what we'll do first of all is we'll mark it as visited, and then we'll look left and we'll look right. So let's just say that that's one of those. Now when it looks left, it's going to look at that and it's going to say, well, hang on, I don't need to traverse this one because we've already been there, so just come back. Okay, fair enough. So that will end that recursive loop there, but it will go over here because this one hasn't been visited yet, and again this one gets called, and guess what, it's going to do two functions. It's going to look back where it was, and it's going to look down one. Let's just say that's a one of these T shapes like that. So again, this is going to look left. It's going to no, I've been here. Okay, fair enough. What about down? Yes, good. This one gets marked as red, but you can see in this case it needs to go. It's going to look up, right, and down, and we'll hit the same issues. We'll hit the same I've seen you already response when it goes up, but it's going to look right and left. And I don't know, I'm just sort of guessing as I go here, just things like that, and so on. So it's going to look throughout, it's going to basically traverse the entire map like this. But what it won't be able to do is reach islands. It won't be able to reach one. Let's imagine this one over here, like this, because there's no way to get to it. So all of this whole section here will be traversed, but any islands that can't be reached will not be hit by this map. Now I hope that makes sense, because this is how I approached this issue. Let's have a little look at the function. Okay, so now we can get rid of you now. So if we go over to map generator, I called I have a function called, where are you? Traverse map. And what this does is it creates a Boolean array. And a Boolean array is going to return if you like, exactly the same rows and columns array as the original map, with a true or false value in each. So true if it's a visited cell, false if it hasn't been visited. So we can initialize it with the rows and columns as before. Because this is a generic C#, or I guess generic .NET type, we don't need to instantiate each visited cell. It's going to default to false. So that's a good start for us. So because with objects, you would need to, for each of them, you'd need to initialize them with a new, but you don't need to with Booleans. For the sake of clarity, I've said a starting column and starting row. So in our little diagram, I might just bring you up and bring up this map in here. There we go. Remember, 0, 0 is there, so we always start with this 1, 1 here. So that's going to be our starting point. All right. And where's our script? And it's going to call traverse cells. It's going to pass this array around, passing also the current row and current column. Now, something to bear in mind here, again, this could blow your mind if you're new to programming, is that an array, all objects, are passed by reference. Okay, so what that's saying is that changes to this will be continued throughout the calls. So we can keep passing this along. If I was to change this end here, new bool, it would dereference it. So we don't want to do that. We won't do that again. Okay, we'll keep that as it is. So this is passed by reference. So any changes will always be updated throughout the calls. So we can safely say that when this is finished, that Boolean should have an array, a multi-dimensional array of trues and falses. Are you bored yet? Thank you for sticking with me. So this is going to call traverse cells, and this is our recursive function. And then this returns that whatever that returned at the end. So let's have a look at this. We know that we're getting our visited cells, which at the moment everything is defaulted to false, and we know our current row and current column, which was 1 and 1. So what it's going to do, first of all, it's going to say, well, have I been here before? Well, we know for the first call that it hasn't been there before. So we won't be calling that. But now we're here. Let's set it to true. Yes, okay, I'm happy now. You've been here, you're here now, and I can mark you as true. And now what we do is we look to see what that map contains. You can see in this first example, it's going to contain this, I don't know what to call it, bottom right or something. I don't know what to call this. I should give them names, shouldn't I? So it's this character here. This one, this guy here. So the top left-hand corner one. So we know what to do. We're going to say, well, okay, I need to look over to the right, and I need to look down a row. Okay, so I'm going to look here. Oh, what do I do there? I'm going to look here, and I'm going to look here. So it makes two calls to itself. It's going to make a call to the column. It's going to make a call with the column plus 1, so that's going to be 2. So that one, and it's going to make a call with a row plus 1, so that's 2. So that's that one. Happy days. And then it's going to break. This is just a standard switch case. If you don't do that, it'll fall through the switch statement. Again, if you need clarity on that, please let me know. That's a pretty standard system of using the switch. You always put break after each piece. And then it was just simply a case of going through each of the possible characters that could be in each one. So for this one, you can see that this points left and points down. So we want to look down a row and also look left a row. I haven't been quite consistent in the columns and rows, have I? This one's a dash, so it's looking left and right. This one's a horizontal line, so that's up and down a row, and so on. This one needs to look up, doesn't it? It needs to look right, and so it goes on until you. The T ones are important because the T ones have 3 possible exits, don't they? These guys you can look up, down, and right in this example. So up, down, and right, and this one is up, down, and left. So you've got row and lines, and this one you've got left, right, and down, left, right, and up, and finally the crossroads, which is all 4 possible locations. Like I say, if it's visited one that's been visited before, it's not going to loop around this forever. If I didn't have that there, this would blow up. It would blow up eventually. It'd just be called too often. And the O, of course, is that one that can't get filled because we've got those pesky, there you go, pesky dead ends. And if we should come across a character that we don't know, oh dear, we've got a problem. But I will put it out to the screen and make sure that we can take a look at why that's happening. So what we end up with, if everything's worked beautifully, is a multi-dimensional array with a whole load of trues and falses in it. So let's do this. Let's just this is the traverse map. So let's just quickly do this. For brackets int r equals 1, r is less than map rows, isn't it? Map rows minus 1, r plus plus, like that, and then we'll do the same for the columns. For brackets int c equals 1, c is less than map columns minus 1, c plus plus, and then we'll say here debug.log cell visited, then we'll say plus r plus comma plus c plus quote space equals space, and then we'll say what's it, so it's visited cells r comma c. How's that? So this is going to go through and just see what's been visited and what's not been visited. So in our current example here, we're expecting to see almost every cell visited apart from these guys down here. So what are we talking? We're talking sort of row. I can't tell from this. It's very difficult. Let's go to the this one here. So you got. So it's going to be this starts. So this starts at 1. So this is going to be row 8. I can't tell what column that is. That is. It's going to be row 8, column 18, column 19, so on. So these ones should be false. These ones should be false. All right, let's run it. Let's run it, people. Let's close this down. Save it. Let's just save this. Yeah. Click on our console. I'm expecting to see a lot of output. Mostly trues. But this is good news. You can see that these columns here, so row 8, column 16 is false, 17 is false, 18 is false. So this whole section there, I'm hoping that the same will be true for row 7. Yeah, false, false, false. This is good. I do apologise if you can't see this. I moaned about this last time. I cannot believe you can't increase the font size. But this is good. So with most of this is true. Look, there's a false there. Okay, 6, 16. Let's just check and see where that might be. That's going to be this fella, isn't it? That's his O here. Okay, this is fine. There's nothing in there anyway. It can't go anywhere. There's nowhere for it to traverse. It can't traverse these pieces, so that's cool. So I'm pretty happy with that. Pretty happy. And if you're not making sense, please be sure to comment. I will do my utmost. I know, as always, I'll provide the Unity package so that you can take it for yourself. Perhaps if you're feeling sadistic enough, you can try and debug this. But it does go, recursive loops. Debugging them are well, let's just say it can play with your mind. You need to be very clear of any other things that could distract you, including me having a sip of my cup of tea. Bear with me 1 second. Oh, it's gone cold. It's gone cold like the weather. The weather was 30 degrees yesterday. Today it's 20 and it's pouring down. Summer is over, but not these tutorials. Alright, so with that said, we've got everything we need now. So all we need to do now is say, well, how can we, in our map, exclude the this piece here from ever being created? And the way I'm going to do that is I'm going to, at the instantiation time, I'm going to check to see if it's actually part of the map, so whether it's visible here. And if it's got false on it, I'm not going to create it. So let me show you what I'm talking about. In here, I think let's just remove that now. We know that works. It's just noise. It's interesting debugging. I'm never sure, because you can put a lot of debugging in and then that debugging gets in the way, and then before you know it, you've forgotten where it was. So in our recursion example, which I'm now going to close down, I've actually already done this. This is the tool that the script that creates the dungeon pieces, and instantiates them here. But it doesn't instantiate them if it couldn't find that character in the map. What's it? The box characters, isn't it? Box characters. Hey. So if it can't find them in box characters, which of course I know I'm not going to be able to find, these ones, then it doesn't create it. So for instance, it won't try and instantiate something if it was one of those O symbols. All right. So what we can also do here now then say, well, okay, well that's good. If you can't find it, continue. But what, or if that cell hasn't been visited. So let's just copy that. Let's put a space. I think I'll just delete that now. So what we're saying, ignoring this because we covered this in the previous tutorial, so please have a look at the previous ones if you want to understand that, or like I say, I'm more than happy to maybe talk it through in the comments. But now we're saying, if it's not been visited, not visited, that exclamation mark that can sometimes catch you out, if this row and column has not been visited, don't instantiate any shapes in there. Let's take a look. Did I do that? Let's just do a save. So I'm going to run this again. By the way, if you're thinking, well, it's the same map every time, that's right, because I'll show you in a sec. The seed at the minute is not being randomly generated. I've put a default value in there. Otherwise, I didn't want to keep guessing and finding different islands. So I wanted to find one that had an island and stick with it. So let's run this again. And if all things being equal, that bottom right-hand side is gone like magic, and we have a map there that is a lot cleaner looking already. Are we done? Maybe. I hit another issue. This is good. This is a good example. And now let me just quickly. Where's my random seed? There we go. You can see I've been tinkering around with this. Let's just do this. Ignoring that 537 for a second. Let's just run this a few times, see if we can. That's good. Something about testing is that you can never find islands when you're doing it in a random way. They just don't appear. Look. So how many times am I clicking this now? Come on. There we go. There's one. You see, there's a missing gap there. Perfect. So it's working nicely. This is working good. If it doesn't find it, then it won't create it. So if this whole thing being traversed it doesn't find this section, it's not creating it. Brilliant. Am I saying that too often? Apologies if I am. It's nearly perfect. There is a problem. And that problem exists when... I'll go back to OneNote here. Can I erase all that? Let's just see. Yeah, come on. There we go. Trusty bamboo pen. I always recommend getting a bamboo pen, particularly for modelling. If we've got a situation where... I'm on the wonk. It's because I'm... Stop it. It's because I'm using the bamboo tablet slightly on the wonk. So we might have a situation where you have at the very, very start, something like this. Or even, something like this. Let's just erase those to a sec. Something like this. Oh, come on, don't do that. Where are you? Pesky dot, I can barely see it. Something like this. So it's going like that, and like that. Sorry, like that. And then like that, like that, like that. So if we did that, if you have this situation, and we start here, that is the size of the map. In fact, you could even do something like this. You can even have these two as a little T-junction. And that would be it. That would be your 6-cell map. And that's not really very good. In fact, I can show you an example because I found a seed that did exactly that. So let's just flip that over on its head. So just control it. X that, 537. I just might pop that over there so I don't forget it. Now if I run this, so I'll just close this down now. I run it. There it is. This is a 4-cell map. Let me just show you in the console. Let's just quickly do this one. Control C. Pop that into Notepad++. There you go. You can see what's going on. We've got this little 4 block here. And like I say, it could be a little bit larger. It could take up quite a bit of space, but it's not big enough, is it, by any standard? So we want to try and avoid this initial sort of small block occurring. Probably the best way to do that, I think, is simply to find that if that does happen, then to recreate the maze. So let's do that now. What we'll do is we will go over to our dungeon generator, dungeon display, and what I'm going to do, I think, on the map generator here, I'm going to initialize the box characters, but then I'm not going to initialize the map anymore, or display the map in here. Okay. And what I'm going to do, so it's going to initialize the box characters over there, and in the dungeon display here, under start, I'm going to run it here. Let's just first of all just see if that, no. map generator, isn't it? So we're going to say map generator, and then I'm guessing the reason those aren't working is because that's probably private, so let's just quickly sort that out. Get valid box characters maybe. Traverse map. Where's my initialized map? Come on, baby. There we go. Yeah, it is private, so let's make that public. I always do that. I always end up tabbing, thinking it's a different application. Come on, you should be working now. I thought you'd work, but you're public void. Oh, initialize box characters. Now that can be private. I bet you were screaming at the screen, weren't you, Richard? You're in the wrong bit. Where's initialize map gone? Initialize map. There you are. There you are, hiding from me. Okay. Oh, I've done it again. Sorry, I keep alt tabbing into the back into Unity. Right, there we go. And that's working. That's well, it's not failing. So let's just run that in Unity. Make sure it still works. It does. Let's quickly change our seed back so that it does create random maps for now. 537. Okay. Now I run it. There we go. And it's working nicely. Look, you can see there's a section down there that's been removed. If you look at this one, has it been removed? Do you know, it's done that thing. It does this all the time. I've noticed this in the last tutorial. But when you click it, what's down here is not what's here. It's you have to click on it to refresh it. It's bizarrest thing. Good, so we're in good shape there. Yeah, that's an empty cell we know about. Okay, let's clear that little area there. This is good. This is good. This is good. Where were we? In our dungeon display, we're initializing them here. And what we can do now is our Boolean visited cells. There we go. So what I think I'm going to do is I'm going to say get visited cell count. Now, where could I do that? Should I do that in here or should I do that in map generator? I think I'm going to do that in map generator. Oh, it's a teaser. It's a teaser. I'm going to do it in here. I'm going to do it in here for now. You can argue out where. So private int get visited cell count. Visited cells count maybe. Brackets bool visited cells. Okay. We don't have the dimensions in here, do we? How does this know? Map generator.map rows. How did it? Oh yes, of course. And map generator is set up there. Lovely. Right, so we can do that. Yes, so we can actually copy this bit here, can't we? And then do that, and then that, and then we'll down here we'll say so we'll say int visited. Not there. I'm in the wrong function. Int visited cell count equals 0. And then this piece here, I think we can say visited cell count. So hang on, so we can say if brackets visited cells C plus. And that will return us how many cells have been visited. So let's have a play with this. Let's just see how this goes. And then we'll do here, we'll do display map art. We'll do that afterwards, and then we'll say yeah, this is fine. Okay, if this isn't quite right yet, if brackets get visited cell count. No, forget that. Let's just print it for now. Debug.log visited cells equals cell count. Get visited cells count. You can get quite confused with these variable names. Okay, brackets, semicolon. How's that? How's that? Oh, I didn't like that. What's this? Oh, does it not? No, it doesn't. Look, it doesn't return the visited cells count, and we should have that because otherwise you're not going to know what it is. Visited cell count. Look, this is confusing, isn't it? I'm going to rename that to visited cells count. Otherwise we've got a problem there. Okay, shift control this. No, we've got a problem, but it's just inconsistent, isn't it? All right. Okay, I think we're there. Visited cells. All right. Now go away, error. Thank you. Boom. And visited cell count equals 135. This is good. Okay, so you can see 135 is a good figure. So I'm thinking maybe if we quickly run this with our dodgy seed. Where are you, seed? There we are. But ignore these ats, by the way. In case you're wondering what that is, that's something we're going to talk about another time. So let's flip that around. Control X. Let's run that again. I'm expecting to see 4, right? We expect to see 4 now because it's only a small thing. I go to console, visited cell count equals 4. So what we could do is we could keep running through this in the dungeon display, and until the visited cell count is greater than 100 or something like that. Okay. So we'll say int visited cell count equals 0, semicolon, and then we'll say while visited cell count is less than 100, no, we don't do that yet. I might do that in a minute. Actually, it could be one of these ones that better be a do while, but bear with me. Yeah, and then we'll say visited cell count equals get. Excuse me. What's wrong with that? Visited cell count equals get visited cell. Control C. Excuse me, guys. Sorry. I think I've done something wrong somewhere else. Now, hoping I've got that right. So what we're saying here is we're going to set it to 0. So this is definitely going to run once, and it's going to initialize the map. It's going to get the it's going to load up the visited cells, the trues and the falses, and it's going to reset the visited cell count to whatever that function returns. And then it's going to loop around. And it's going to say, well, if it's less than 100 still, then do it again and again and again and again. Now this is going to fail all the time I'm using that seed, isn't it? So let's just. That's dangerous, isn't it? Actually, if you think about it, because I'm using a default seed here. So let's quickly change that now. It's going to be hard to see this, isn't it? What I might do to prove this is working. Could get stuck in an endless loop, possibly. I don't know. Perhaps we could do a for loop or something. I don't know. I just want to see it. It's not going to work as I'd hoped. Sorry, I'm being verbose here, but what I'm trying to say to you here is that there's no real way to see if this is working because you don't know if it's worked the first time. In fact, what we could do is we could try something like this. Debug.log. Found a small map. Trying again. Okay. Oh no, let's just say map size equals 0. Current map size equals plus visited cell count plus, I should say dungeon, shouldn't I? Current dungeon size. I suppose. Retrying. Okay, now I know that's going to always say it, isn't it? The first time. Current dungeon size is... and round it goes. Now this is going to fail badly. It's going to get stuck in a never-ending loop all the time that this is 537. Because it's always going to return less than 100. So let's just try that. Oh. Alrighty, people. Oh, lots of errors. Visited cells. Yes, that's right. We can get rid of that now. Okay, so we need to change that there. We need to move that here. So bool visited cells. Move it outside of the loop, otherwise it will not be available. How are you? Hang on. What was it before? Hang on. Traverse map. Let's just see. Hang on. Did that do it for us? Oh, it does. It does it for us. So I don't need to instantiate it up here. Oh God, where did I go? Where did I put that? Here. Sorry. So I don't need to do that. That gets created for us every time. Okay, people. How's this going? How are we looking? What? What? I just did the... Did I type it wrong? Excuse me? What have I done wrong? Use of unassigned local variable visited cells. But I put visited cells there. Did I type it in right? No, that's right. Bear with me, I'll have a look at that. Okay, I worked out what it was. Because this hasn't been instantiated, even though this traverse map does instantiate it here, this actual element here doesn't like that. It looks as though it's one of those rules that says it has to be instantiated even if it does sort of compiler check to make sure that something's instantiated, which is curious. It's a shame it couldn't let us away. So that's the command you need there. Just to initialize this, it's a bit daft because if I just show you this instantiates it straight away. So how'd you go back there like that? So it's a bit pointless, but there we go. So I've instantiated that now. So what we're saying here is we're saying the current dungeon size is that, retrying, and then it's going to go around. It's going to keep going around until the dungeon size is greater than 100, and then it's going to display it. So I'm imagining the majority of the time this will work first time. Dungeon size equals 0. Retrying. There we go. So yes, it's always going to be 0, isn't it? Okay. What would be really handy, maybe if I could try something like 135. I don't know what the actual size of it should be. Let's just see. Let's just see if I get lucky. No, so it always, when it says 0, it's the first time. I'm just going to try a few times, see if... you know what I'm going to do? I'm going to move the console into its own window because this is driving me nuts. This game window, it just defaults to the game window. I don't want it to default to the game window. So how big is that? It doesn't actually tell me the size, does it? So that's annoying. Yeah, so let's knock it up a notch. Let's try 140. It's just... there's a fairly good chance this is going to crash if I go down this road because it's never going to be able to create a maze that big. Come on, click that, thank you. Okay, that's retrying on 100. 140 seems acceptable. Let's just keep creeping up. 142. Obviously this is a huge size. Perfect. Alrighty, now you can see what's happened here. It's done current size equals 0. Maybe you can't see what's happening. It's so flipping small. Let me bring that into Notepad++. And now it's too big. So it created a dungeon. That dungeon size was 140. Very big. But it wasn't big enough for us, so it retried it. And so that's good news. We don't need it to be that big, but we'd like it to be something of a decent size. So if we just say set that to say 100. In fact, why don't we even have a value up here? Why don't we even have a value up here, people? It just says public int minimum maze size equals. Oh no, hang on. We need to be careful here because it depends on the size of the rows and columns, doesn't it? Ooh, that's a thought. That's a thought. So let's quickly just do this. Let's have a look. Let's just output the size of this. Visited cell count debug.log brackets visited cell count equal count equals plus visited cell count. That'll show us how big it is. Now, obviously we know roughly how big that's going to be now. We can leave that at less than 100, that's fine. We don't want that minimum there yet. So we need to crack on and say so we're going to get the current dungeon size is retrying. Okay, so let's just quickly run this again. And we've got our cell count is 144. Now if I close that down, just go to our game manager. Over here we've got our rows and columns. So 144. So let's change that to so what is the maximum number you could have in those cells? Let's just have a little think. It's going to be that 18 times 8 times 18, isn't it? What's 8 times 18? That's the maximum number of cells, isn't it? Because that would mean that every single cell was taken up. 144, there you go. 144 cells is the maximum. So what we could do is we could have a percentage perhaps. So we'll have a public float up here. We'll say minimum maze percentage equals 80f. And then we're going to say here, this is going to be slightly confusing, is less than map rows minus 2, that there minus 2. The reason I'm saying minus 2, by the way, is because there are x's either side, multiplied by, and I'm going to put that in brackets as well just to be absolutely clear that the minus 2 is taken into account first, multiplied by map columns minus 2, so I need to put that in brackets as well, times minimum maze percentage. I'm going to put this all in a function right now, in a separate variable now. It's just okay. Int minimum maze cells equals, and we can get rid of all of the brackets. That times maze percentage. Now the thing that bothers me about this is that maze percentage is a float. It might be kind and round down for me. Let's just see. So now we're going to say the minimum maze cells is that minus 2 times columns minus 2 times the maze percentage. So that is those two values there are the maximum number. It's not 80f, is it? It's going to be 0.8f. F. Otherwise it would be massive. Righty, let's try that. I think they might throw an error. Let's just see. Yeah, you can't pass a float to an int, so what we might need to do is say int. This might be kind. That might be kind if we try and cast it. Int dot parse. Brilliant. Is that going to be kind? Is that going to be kind? We've got our variables. Int dot parse. Come on, baby. Has some invalid arguments. String. There's no string in there. Oh, maybe int dot parse requires a string. Int dot. Oh, blast it. Bear with me 1 second. I'll find out how we get this to the. I think it's math.floor, to be honest with you. Math f dot floor. That returns a float, so maybe math dot. I thought it was floor. Floor to int. That's the fella. There we go. There we go. Did no pausing required. I remember that one off the top of my head. Alright, now let's try it. Errors? Clear off? Thank you. So what we're saying here is that the rows and columns, where are we? So we're multiplying that by this percentage value here. So it's saying that basically we want at least 80% of the cells to be covered. Otherwise, we're not happy. In fact, we could even do this. We could current dungeon size, and then we'll say which is less than the required plus minimum maze cells plus quotes. There we go. A little bit strong, but badoom. Current dungeon size, which is less than the required 115. Okay, let's just see if our maths ties up with that. So we got where are you? Where are you? Where are you, calculator? Did I close you down? Fool. Calculator. So is it? So it's 18 times 8 times 0.8. 115.2. Fine, it's rounding down, whatever, we don't care really. I think we're getting nitpicking like that, then who cares, right? So good. And then what we can do now is we can pop back into here and make this a bit bigger. So let's make it 20 by 30. Click on there. Bit bigger. You can see some spaces there. That's fine. And there we go, and it's got a value of 403. Look at that. That's a lovely looking maze, isn't it? Look at this long line here. God, imagine getting to the end of there and going, oh, blast! Coming all the way back. And it's removed those sections for us. So, wow, people, what have we achieved today? We've achieved a lot. We've actually really cleaned up our maze generation algorithm in a big way. We've removed islands, and we've made it such that you can't start on a small island. So this is really good. We still haven't got to the dead ends yet, and I have an answer for that, and it's a lot more simple than this one, and we'll cover that in another tutorial. I want to thank you for still being here. I am proud of you. You have really stuck this one out, and as always, I will check this stuff in. I'll keep the recursion example script in there, should you wish to use it, you lunatics. And encourage you, like I say, if you feel inspired by that, go and have a look at Towers of Hanoi. Go and write your own recursive algorithm. See if you can change the world. And I look forward, guys, to seeing you next time. We'll take a look at those little dead ends, and then we'll start to create some models for our tunnels, and we'll create an actual game. I'm excited about that. Thank you for persevering. I look forward to seeing you next time. Have a great day. Cheers now. Bye bye.